All right, should start. Okay, good. Okay. So again, hi guys. It's really great that all of you guys could be here today. Mentees, mentors, family members, even. And thank you guys so much for coming to the science fair, where we're essentially going to be having our so the plan for today is we're really going to be having our mentees just go one after another. As a lot of you guys probably know, basically you'll be hearing a 12-minute presentation, which will be followed by 8 minutes of Q&A from our judges. And each mentee will get judged twice, or there will be two judges, and they will only be doing it once. So, and again, one of the things we just wanted to say is thank you everyone for coming. And, this is the representation is sort of a culmination of our mentorship program for a lot of these mentors and mentees. So it's really great to be able to see and get your work judged by some people who have expertise in your area. All right, so let's get started with our, yes. So Jacob, about that, what we will be able to do is because of the tight the tight nature of our schedule, we were unable to actually directly ask questions. But one of the things we do recommend, is if you have any questions for a mentee per se, right? If you can direct message me, I will reach out to that mentee directly and get back to you if that helps. Because again, this is a science fair. So what we're trying to get this running, because there are a decent number of people, and each of the presentations always takes 20 to 25 minutes. So does that answer your question? Yeah, so I mean, I don't know if you guys do have the ability to, participant can chat with everyone. I think you should be able to chat with everyone. So yeah, so you can totally chat with them after their presentation, of course, and not like disturbing them during their presentation. Okay, so again, like we're going to get started now, and our first presenter is going to be Angel. So basically what I'm going to do is I'm going to pin you, Angel, and then you should be able to share your slideshow, right? Using share screen, and then you can get started. All right. And again, I'm going to, before we start, I'm going to ask that everyone please remain muted unless you're a judge who's asking questions after she's done with her presentation. All right. Okay, give me a second here. Just pin you first. Spotlight for everyone. Here we go. Okay, yeah, so you can go ahead and share your screen, and then we should be able to hear you, hopefully.
It says that the screen is disabled. I can't share it yet.
On my side, it does tell me that
oh, it's working now.
It's working? Good.
Okay. Good afternoon. My name is Angel Shah, and I'm a junior at Walpole High School, and I am presenting a project, and it's on the effects of social determinants of health on attitudes and perspective of the flu vaccine. So social determinants of health, such as schooling, race and ethnicity, socioeconomical status, access to healthcare services and vaccination, and workplace or school policies may affect influenza diseases and outbreaks in the United States. Access to healthcare is less likely for social and economical deprived communities and vulnerable racial and ethnic minorities. The increased risk of severe influenza disease, hospitalization, and premature death is in vulnerable communities. So many social determinants cause disparities in the exposure to a vaccine, getting the vaccine, and treatments to help ease the effects. These are the effects of inequalities, which means people who are affected more deeply by social determinants of health have an unequal chance to prevent or fight off the disease, and those people have an increased rate in death rate. Many people have different perception of the flu vaccine, possibly due to social determinants of health. underserved population, education, finance, and age groups. For example, research has shown that parents who do not vaccinate their children against influenza typically come from the decision from their doctor who has not encouraged or recommended it. As this ties back to social determinants, many higher level people generally feel safe and at low risk from the virus. Many parents assume that their children is not vulnerable to the flu because the child is otherwise safe and has no high risk disease because of the location they live in. Furthermore, in some ethnic groups, CDC found that about 44% of African Americans and Hispanics over the age of 6 months were vaccinated against influenza. The likely reason for this is because of the racial background, as it plays a role into the social determinants of health. Non-white racial groups tend to have a greater apprehension because they tend to have unequal access to healthcare. Also, different states have different perceptions, as in 2006, a study showed that adults in Nevada rather wanted to get the flu than the vaccine. Many people are also hesitant to receive the vaccine because of their spiritual or personal beliefs or just health concerns such as allergies or weak immune system. So in order to conduct this experiment, we used a Google form survey that was designed to ask questions about the vaccines to different groups based on age and race to understand their perception on the flu vaccine. And we used a Google form survey because it's a free online tool that allows users to collect data quickly and effectively. And the questions that were asked on the survey are the ones on these slides. The survey starts off by asking their age and ethnic group and racial group to know a bit about their background and to observe the variety of people who answered the survey to understand their data. The next questions ask if they have received the flu vaccine in the past to understand if they believe in the vaccine. We also asked about their personal information, such as the level of education, the location they live in, and their income to know whether or not social determinants of health has any correlation with the survey participants' decision to receive the flu vaccine. So again, to clarify, we're looking at social determinants of health, and we included income, highest level of education, race, and ethnicity, and the area they live in, and we compared those individual on whether or not the individual received the flu vaccine in the past. This allowed us to see if there's any correlation between social determinants of health and whether an individual received the flu vaccine. We had 32 survey participants and we compared those social determinants of whether or not they received the flu vaccine. And for us, in our results, it showed that there were no correlation. As for my results showed, it did not correlate with the social determinants of health and whether or not an individual received the flu vaccine. But for next time, I would make sure I have a bigger data set to get an accurate result. We would also need to survey various types of population and not just those who have access to things like the internet and education. And our population was biased as we seek out participants that were family members or friends or just members of a higher education group. Also, we plan on analyzing more data on their perceptions on the flu vaccine. And thank you to IPARS for giving me this opportunity to present this project, and I'm happy to present any questions about my project.
All right, thank you. So now we're going to move into our 8-minute question section. Thank you so much for your great presentation. So Kevin and Raga.
Hi, Angel. That was a really good presentation. Congrats to completing this IPARS journey and doing a successful project. I had a quick question about your project. So do you have any plans in the future of what you plan to do? So maybe you can try sending out a survey about a COVID vaccine or something, but do you have any other future plans?
Yeah, so for the future plans, in the survey itself, we did ask more questions. We just did not get a chance to analyze those yet. So for the next direction, we plan to analyze more data and their beliefs on the flu vaccine or not too.
Okay. Thank you.
Hi, Angel. Thanks for presenting. I also have a quick question. How many responses did you receive for your survey?
We received 32 participants.
Thank you.
I have another quick question.
Mhm.
So how exactly did you analyze the data? Did you just look at the different numbers and compare them, or did you do some other type of data analysis?
So we asked like the questions on the Google Form slideshow, and in the results page, you saw the percentages. So in some of them, it said 100% yes. That means they all did receive the flu vaccine in the past. However, in one of them, it asked for their income, and for less than 50K, some people did say no, they did not receive the flu vaccine. So it was like 12.5% said no. So we converted everything to percentages.
Thank you.
Right. So I think what we can do is, I think since Jacob did ask, and I think that's a good point, since we do have some time left, right? So what we'll do is the rest of the time that we have left in the judging section, we will allow the public to ask questions. So you can directly ask your question, Jacob, if you'd like.
Oh yeah, thanks. Sorry, I didn't know if we just answer in the chat or not. I just wanted to, I thought this is like really important work, and I thought it was really cool. I wanted to ask, I guess this took like the approach of access to healthcare. I wanted to ask, I guess, how you would even go about assessing the perspective of historical hesitance, meaning like even in patients who do have access to healthcare, whether they would be apprehensive of the medical system simply just because of, say if their group has a history of abuse by the medical system. I guess the example I brought up is like hesitance in Black communities because of like historical abuse of Black populations, like in the Tuskegee medical Tuskegee syphilis experiment.
So I think what you said does make sense. I think it's also because for those types of like for them, it's harder to get access to healthcare too. So I feel like it's harder for them to get into vaccination sites just because of their location they live in and stuff. So I think yes, those do have a factor on that.
You mentioned earlier sometime during your presentation about how you plan to try to get people, other people who with different demographics to respond to your survey. So for example, people who don't use internet as often. So how do you plan to do those kind of things to include everyone of other demographics as well?
So for them, like, because it's harder for different people to get like internet access or just education in general, maybe like giving those surveys to like local libraries or just local places that people would want to fill out and then get back to us after, and then we can analyze those data set.
Okay, thank you.
All right. Any other questions from the public? Going once, going twice. All right. Thank you so much for your presentation, Angel. I really enjoyed it. So now I'm going to, I should be able to, so if you could please mute yourself and then I'll just take the spotlight off of you. All right. So if you could just, yeah, just mute yourself. Okay. So our next presenter is going to be Arindam. And yeah, so let me just go ahead and spotlight you here. And then we should be able to spotlight for everyone. Great. And you should be able to share your screen and just go ahead and do your presentation. All right. Okay, so again, just a reminder, if everyone can please mute themselves.
Okay. I guess I'll start now. So oh, I got something in chat. Hi, my name is Arnam Baga, and I am doing a proposal project, and I'm a sophomore. So I'm proposing a fusion protein to treat Gaucher disease type 1. So Gaucher disease type 1 is a genetic disorder caused by a point mutation in the gene encoding for glucocerebrosidase, an enzyme that breaks down the fat glucocerebroside. This mutation prevents glucocerebrosidase from functioning properly and causes glucocerebroside to build up in the lungs, liver, spleen, and bones. Although some therapies treat Gaucher disease by directly providing glucocerebrosidase for the rest of one's life, they're typically very, very expensive, up to $300,000 per year. So now you may be wondering why I chose this specific disease and like what really made me interested in this project. And this, like what really made me interested was when I like stumbled upon a video of a young child having this disorder, and watching her experience really touched me as I found out how challenging her life really was. And then in addition, her treatment costed a whopping $24,000 a month, which is obviously a lot of money. So I aim to design a protein that will go into the nuclei of affected cells and edit the DNA in a way that will permanently change the mutation back to the normal sequence, helping people with this disease. So the protein I've designed is a fusion protein based on recent developments in Cas9 base editing technologies. So here's some like introduction to Cas9. So CRISPR and Cas9. So CRISPR, which stands for clustered regularly interspaced short palindromic repeats, describe repeating palindromic DNA motifs separated by spacer DNA and were first discovered by Yoshizumi Ishino in E. coli. So the spacer DNA was found to contain short segments of viral DNA, and these DNA segments could be transcribed into RNAs that bind nuclease proteins termed CRISPR-associated, or Cas, proteins. Interestingly enough, when bacterial cells were infected with DNA from a bacteriophage virus, the RNA Cas complexes were found to bind and cleave the invading DNA. Groups such as those of Dr. Jennifer Doudna and Dr. Emmanuel Charpentier have studied the mechanisms by which RNA Cas complexes recognize and cleave DNA. So these groups found that Cas proteins commonly bind two RNAs, a CRISPR RNA and a transactivating tracer RNA that connects the Cas protein to the CRISPR RNA. So this tracer RNA, CRISPR RNA chimera, is also called the guide RNA. And the guide RNA Cas complex denatures DNA for recognition. And when the guide RNA hybridizes with one strand and the Cas protein recognizes a protospacer adjacent motif or PAM sequence on the other, the complex cuts like both strands of DNA. So despite this power, there aren't any existing CRISPR systems for the treatment of Gaucher disease currently. So in Gaucher disease 1, the DNA of the GBA gene on chromosome 1 contains a GC nucleotide pair encoding for an AGC serine codon instead of an AT pair encoding for an AAC asparagine codon. So the fusion protein that I designed can specifically bind to this region of DNA and convert the cytosine base to thymine, fixing the mutation. So in my fusion proteins, several proteins are connected with flexible serine or glycine linkers. In the middle of our peptide, we have our Cas9 protein, which is called SpCas9, the most commonly used Cas9 variant for the type of modification we aim to make and the types of nucleotides surrounding our target. Our Cas9 is connected to the cytidine deaminase or ApoBac1, an enzyme that chemically converts Cs to Ts in DNA. Finally, Cas9 is also connected to the uracil glycolysis inhibitor, also called UGI, which promotes proper base editing in a nuclear localization sequence that allows the protein to be transported into the nucleus. This system also requires engineering a guide RNA that can bind to the Cas9 protein and base pair with the glucocerebrosidase gene. So here's how my proposed protein would work. So once the protein reaches the mutated sequence, the bases on the guide RNA will bind to the mutated sequence. And because most of the bases in our guide RNA are complementary to the mutated sequence, our guide RNA is very unlikely to target other DNA sequences in the genome. Then the cytidine deaminase in our protein will chemically convert the C in the mutation, so the C in the mutation, to a U using a hydrolysis reaction that converts an amino group to a carbonyl group. So the cytidine is converted to a uridine. Now with a U in the DNA, special repair nucleases in the mismatch repair pathway realize that something is wrong with the DNA, and they have a choice. So these nucleases can remove the U using uracil glycolysis and replace it with the original C, bringing the DNA back to how it was before. Or these nucleases can remove the G and replace it with an A. And obviously, we want to promote the second scenario because that fixes our mutation. So this is why our protein includes the uracil glycolysis inhibitor, as I mentioned earlier, which has been demonstrated in other CRISPR-Cas9 systems to prevent the first choice from happening. Previous studies of the CRISPR-Cas9 system suggest that eventually the same DNA repair pathways will replace the U with a T to create the proper AT base pair. We propose that this will allow cells to once again produce functional glucocerebrosidase. The safety. So targeting of Cas9 to a desired gene locus requires the recognition of PAM, or the proteospacer adjacent motif that I mentioned earlier. And PAM, so while various like Cas9 variants have been developed to recognize different PAM sequences, the wild type SB-Cas9 that we are using recognizes an NGG PAM, and the editing window for most Cas9 proteins contains the nucleotides 13 to 17 positions upstream of the PAM. The fusion protein and guide RNA proposed in this work will target a TGG PAM, 14 nucleotide downstream of the desired edit site, which is consistent with the requirements of the wild type SB-Cas9 we have used. A blast search also of the human genome did not return any off-target sites that may be found by the proposed guide RNA, with the closest match being a locus in the growth hormone receptor, GHR gene, with 5 mismatches. Altogether, these findings suggest that editing of the proposed fusion protein would not result in any undesirable off-target edits. So now I'll briefly walk you guys through the 3 steps we envision for completing this project in the lab. So the first is obviously expression and purification of the fusion protein and the guide RNA. So what happens first is that I will insert the proposed CRISPR RNA fragment into the PFYF1320 plasmid, which contains a single guide RNA scaffold, and using CR cloning to produce a final plasmid that may be transcribed to give the single guide RNA. We will then also express a fusion protein by cloning its DNA sequence, and we'll also include an 8 histidine tag and put that into the PD881 SR plasmid, which will then be transformed into E. coli cells. And the E. coli cells will then be cultured, and the expression will be induced by adding L-rhabinose, and the cells will then be broken up, and the fusion protein will be purified using solid beads containing nickel, which bind to the histidine tag, which will obviously separate the fusion protein. So the second step is demonstrating consistent and on-target editing. So we will confirm the editing activity in vitro in macrophages carrying the mutation, such as those obtained by differentiating induced pluripotent stem cells derived from skin cells of Gaucher disease patients, as macrophages are the types of cells most commonly affected in the disease. We will mix the purified single guide RNA and fusion protein together and use electroporation to transport the complex into macrophages. We will obtain the cell's genomic DNA by lysing them and degrading the protein components. We will then use Illumina high-throughput sequencing to characterize the protein component. We will use the Illumina high-throughput sequence to characterize the genomes of the treated cells, and confirm the edits at the target site and characterize any off-target edits that might have taken place. We will also measure the amount of glucocerebroside in edited and unedited cells to confirm the proper glucocerebrosidase activity. And our final step is successful delivery of the fusion protein. The engineered fusion protein would be expressed in vitro, encapsulated in lipid or adenoviral nanoparticles, and injected into the body. We will test the delivery of the fusion protein guide RNA complex in vivo using a mouse model for the Gaucher disease. To deliver the CRISPR components to the mice, we will encapsulate the ribonuclear protein complexes within lipid components, which will help retain the activity of RNPs in addition to redirecting it to the target DNA sequence after low-dose intravenous injections. This methodology is applicable with 3 classes of lipid nanoparticles, including dendrimer lipid nanoparticles, stable nucleic acid lipid particles, and lipid-like nanoparticles. And previous studies indicate that the approach that's highlighted here is applicable to many gene editing areas, including the reversal of mutation of Gaucher disease type 1. So what are the outcomes? So the successful development of the proposed Cas9 cytidine deaminase fusion protein would result in a vastly less expensive and less frequent treatment for Gaucher disease type 1. Such a system would make treatment for Gaucher disease type 1 significantly more accessible to patients, greatly improving the quality of life for many. Additionally, the proposed project involves the optimization of a variety of techniques to ensure safe, on-targeting gene editing with the Cas9 complex. As such, this project would contribute to ensure safe, on-target editing with this project would contribute to the broader scientific efforts towards developing best practices for safe and controlled CRISPR-Cas9 gene editing projects, and may inspire the development of similar Cas9 base editing systems for treatment of other diseases. And here is my works cited. And thank you so much for watching.
All right, thanks, Arindam. Question, could you put your slides back up? I'm sorry to ask, but I just have a few questions if we could just go over a few things. Okay. And I just want to say before we keep going, all of you guys are doing a great job, and I think that was the work you've done is really amazing. Could you go back to slide number, I think it was 7. No, forward. Here, yes, here. No, one back. So could you again just quickly explain what exactly is this uracil glycosylase inhibitor doing?
So as I mentioned, the uracil glycolysis inhibitor is to make sure that the mutation does not return back to its original thing. So as you guys can see in this step, right? So there's 2 ways that the cell can fix the mutation. If we have a UC, right, and then we replace the C with a G. So either the cell can take out the U and replace it with a C, but that will just get it back to the original mutation, as you guys can see here, GC, right? We don't want that. What uracil glycolysis inhibitor does is that it inhibits uracil glycolysis, which does this process. So what happens is that we go to the healthy.
I understand. Yeah, that makes sense. Okay, thank you. I mean, one other question I had was, could you just speak a little bit more, going back to Gaucher's disease in general, could you just speak a little bit more about, how did you get to this point where you sort of came all the way from, hey, I see this problem, to this is specifically what I want to do. Do you want to just speak a little bit more about that?
Yeah, so I think I mentioned, so I actually stumbled upon a video. This was before we had the idea in mind, but I stumbled upon the video of Gaucher disease and of a little girl having it. And once I saw it, obviously the girl was having trouble, right? And the cost was very expensive. And I did some more researching into it, and I found out that it was a point mutation disease. And from there, I was like, oh, and then I was also learning in my biology class about CRISPR-Cas9. So I kind of connected those 2 subjects together, which was pretty cool. So I got to learn more about both subjects.
Great.
I have a few questions. So first, congratulations. This is a tremendous accomplishment. Great work here. So I guess my first question would be the difference between the injections and this new protein you're creating. So we already know that the injections, while expensive, they have successful results in treating children and adults with this disease. So I guess my question would be, what are the similarities of the pathway of this new protein and/or in comparison to the injection, just to make sure that when this protein is injected, or into the body, that it will actually have results and not just kind of you know, reverse what it could potentially be doing.
Yeah, so I think I talked about, so obviously the first difference is price, but the injection that is currently there actually provides the glucocerebrosidase to the person, but that is obviously very expensive. So our fusion protein will obviously be will also be like injected through injections, but it will deliver the fusion protein. It won't deliver the glucocerebrosidase. And I think I mentioned the 3 steps that will ensure for safety. So like obviously we'll go into the lab and we'll obviously have to make sure that it demonstrates consistent and on-target editing. And we'll have all these 3 steps are like the 3 main basic steps, but obviously we'll have like more steps to make sure that it actually works before like confirming its like activity, that like, oh, you can have it. So
Thank you. Can you just clarify? I know you mentioned about testing it in vivo and in vitro. Can you just clarify your procedure for testing it there?
yeah, so the first so I guess I'm on the slide. So we'll confirm the editing activity, so in vitro in macrophages. And macrophages, these cells carry the mutation, and we'll derive them from the skin cell of the Gaucher disease patients, which macrophages are the like types of cells which are the most commonly affected in them. And then we'll try like putting the protein in these cells and making sure it works. And then after like these cells, like we insert it, after a while we'll use I said Illumina high throughput like sequencing to make sure that the DNA is actually changed and like the glucocerebrosidase activity like returns to normal. And we'll also characterize any off-target edits and any ways to like fix that if that's possible.
Emily, do you have any other questions?
I don't. Do you want to open up to the public, see if they have any questions?
Yeah, that's what I'm thinking. Yeah, public. Did anyone else? Do you guys have questions for Arindam? All right. I mean, Arindam, very, very nice job. And we're really proud of you. Angel, you too. So if you could just unmute yourself, and I'll just remove you from spotlight, and we'll move on to our next presenter. So here since Emily's also a judge for the next person, we'll just give her like 30 seconds to get the next rubric up, and then once she's ready, we'll go ahead and start the next presentation.
All right, you're good to go.
Sounds good. Okay. So our next presenter is going to be. Okay, Sri Gauri, you're going to be our next presenter. So if you can turn on your camera and
yeah, okay.
Let me just, if you can, so that I can hear now. Let me just try to, before you do screen share, let me just spotlight you.
Okay.
Here you go. You should be spotlighted now. Okay, so
yeah.
If you're ready, I'm going to start your timer. All right.
Yep.
So
okay.
You can go ahead. Good luck.
Yep. Okay. Hi everyone. My name is Sri Gauri, and I'll be presenting a project around solutions and liquids. So my inspiration for this experiment is based on an important daily activity that I do, which is drinking water. And I especially like drinking warm water during the colder months of the year. However, water has a tendency to reach room temperature quite quickly. I've tried using different water bottles and thermoses to combat this, but they never seem to work since the water reaches room temperature by around 30 to 45 minutes. These products are also quite expensive and only hold a minimal amount of water. So that got me thinking, what could I use to help water maintain its temperature for longer and in a more cost-effective way? After gathering all my materials, which are found around my house, I hypothesized that socks would work the best to help water keep its temperature. Here's our procedure. Essentially, I took 2 beakers of different sizes and placed the smaller beaker inside the larger beaker. After that, I placed the insulator between the 2 beakers. The way in which I wrapped the insulator depended on the material itself, but generally I made it into like a cylindrical shape and placed it between the gap of the 2 beakers. After that, I warmed 150 milliliters of water in the microwave until it reached 40 degrees Celsius, and then I poured the water into the smaller beaker. After that, I covered the larger beaker with a cardboard circle in hopes of preventing convection from occurring, as I wanted to focus the study around minimizing conduction. After that, I placed a temperature probe through the hole in the cardboard circle. After repeating this process for each of my 27 trials, I gathered all my data and organized it into different tables. Here they are. I also made some graphs. The graph on the left shows the collective temperature loss of each insulator in the control, while the graph on the right shows the gradual temperature loss per minute. These graphs show the temperature loss per minute of each material and each insulator, but they vary slightly. The graph on the left has a distinction between the control and the insulators, while the graph on the right does not. I also calculated the standard deviation value for each of my insulators and the control as a way to identify how much variation was present in my data. And to calculate this, I used this sample standard deviation formula. Here are the values. One thing that I noticed throughout all my trials was that the temperature dropped at a faster rate in the beginning few moments of my trial compared to any other moment in time. After those initial few moments, the temperature dropped at a steady gradual rate. Now that I had all my data, I could finally answer my original questions. I could use socks to insulate my water for longer. To back this up, I used my observations, data tables, graphs, and standard deviation value. Socks had the highest ending temperature, the lowest temperature climb per minute, the lowest collective temperature loss, and the lowest standard deviation value among the materials tested. These classifications point to and prove that socks are the most effective in helping water maintain its temperature. I also deducted that bubble wrap was the worst insulator because its performance was defined in terms that were the exact opposite of socks. It had the lowest ending temperature, the highest temperature climb per minute, the highest collective temperature loss, and the lowest standard deviation value among the materials tested. Now, after doing this experiment, I learned 2 things. First, that water loses the most warmth when it is first heated or cooled. This is due to the fact that the rate of heat transfer is directly proportional to the temperature difference of the 2 objects. I also learned that water usually loses 0.1, 0.2, or 0.3 degrees Celsius per minute. To explain the results, I inferred that the general thickness, ability to trap air, and general radiation protection contribute to each material's success or failure. For example, socks were generally thick, could trap air, and provided some radiation protection. Consequently, they are the most effective. However, bubble wrap was relatively thick, couldn't quite trap air, and did not prevent radiation in even the slightest. Thus, it was the least functional. When explaining my results, I also had to think about potential errors in data collection, the procedure, and other areas. I can confidently state that I collected enough data. Executing 6 trials per each insulator increases the probability of gaining accurate and precise results. As for the procedure, there is definitely at least one change to be made. Looking back, I realized I should have warmed my water on the stove instead of the microwave, as the stove provides even heating while the microwave does not. This could have interfered with results. Also, there could have been a variation in the placement of the cardboard circle, as everything was being placed relatively in the same position, but there was no way to make sure that it was being placed in the exact same way. This could have led to more area being exposed in one trial compared to another, decreasing the temperature of the water in that specific trial. To add to this experiment, I could test different metals or liquids that are not water. Lastly, we've looked at each material's efficacy but not its durability. This is extremely important considering that most of these materials cannot be washed in a dishwasher or by hand like a thermos can. The entire point of this experiment is to find a cheap alternative to a thermos, so this factor is important. Overall, bubble wrap and damp paper towels are likely the least durable because they can get easily damaged, making them useful only in the short term. For long-term coverage, socks are the best because they can be washed and don't obtain holes easily. My ending thoughts are that I should have paid more attention to radiation's effect on water's heat loss. I did consider convection's impact, and that's why I used a cardboard circle, but I could have done a better job and taken other measures to limit convection. Originally, I thought that conduction was the only form of heat transfer that was going to occur, but I forgot to think about other forms. So, in the future, I'm going to make sure that I don't overlook or assume any details during my background research. Here's my bibliography. Thank you for watching.
Hi Shrigori, congratulations. Good, it was a good project. I had a question. You were talking about standard deviations, and I wondered, did you ever consider comparing it to a real insulator that we use in the real world, like a thermic insulator like PTFE, or even just insulators that you see, I don't know, like at Starbucks, like cardboard or something? Did you ever consider comparing it to those empirical values that you might find online?
Yeah, I did consider that, and I was thinking about maybe if I was going to like extend this project, I was thinking about doing that, like maybe even comparing it to like a thermos, like a professional thermos, like a Yeti tumbler or something. But yeah.
And I had another question. So did you standardize the initial temperature of the water? So you put it into the microwave, and then you put it into a new cup. Did you measure the temperature then?
Yes.
So
Yeah.
were all the temperatures for all the 6 trials the same?
Yes, they were all the same. It was 40 degrees Celsius.
Okay, got it. Thank you.
Awesome job. I kind of have a little bit of a follow-up question to the one Yash just asked. So you talked a little bit about if you were to continue, that you would pay more attention to what other forms there are. So what specifically would you look at? Like kind of what Yash was saying about different thermoses. Do you have any a specific idea that you're gonna continue on?
Not exactly, but I think definitely I'll definitely in the beginning I thought that conduction was like the main form of heat transfer, so I learned a lot more about conduction than I did about like convection or radiation. So if I was going to like focus on a different form of heat transfer, I'd definitely like learn a lot more about it, and then maybe I'd find like some other way. So for right now I don't really know, but in the future if I research more about it, I could probably find a way.
Shigori, I have one more question actually. So I think you had said that one of the main factors, or one of the factors in that you'd noticed differentiated socks, cardboard, or not cardboard, aluminum, and the other 4 materials you use. You talked about the ability for the material to trap air. So where did you come, or how did you come to this conclusion? The ability to trap air had an effect.
Well, I read in an article like I don't exactly remember the exact reason why I chose to include air, but I read somewhere that like the ability to trap that air is like that air is like a conductor, and that like it spreads heat. So if a item can like trap air, then it can like also I guess like reduce heat transfer from occurring.
Interesting. Okay.
All right. Let's turn it over to the public. Anyone else have any questions for Shrikari about her project?
I had a quick question. Thanks for your presentation. I thought it was very informative, very interesting. I wanted to know, I guess, why might the temperature have dropped more towards the beginning of the experiment than towards the end? Why do we see it drop so fast at the beginning?
Yeah, so I think I like briefly mentioned this, but at the beginning, the difference between the water and like the surrounding air is higher than it is like in the middle of the experiment, because the water is like slowly decreasing. So the larger difference between the water and the surrounding air is, the faster heat transfer will occur. So at the beginning, that's why it occurred faster than throughout like the middle, because by the middle the temperature difference slowly dwindled, so the rate of heat transfer also like decreased.
Thanks so much.
All right, any other questions, guys? Okay, well, thank you so much for a wonderful presentation, Srigari, and if you could just mute yourself, I'm going to try to remove your spotlight and move on to the next person. All right, so, okay, so our next presenter will be Tanish. So since Emily will again be judging this one too, we will give her maybe a minute or so, and after that we will begin. Tanish, if you could unmute yourself and turn on your camera, then we can see here. Yeah, he's here.
Okay, so I'll share my screen.
Yeah, so just hold off for a minute or so, and then I'll just spotlight you for that. I'll let you know when Emily's ready, or when all of us are ready. Give me a second here.
I'm good to go.
All right, yeah, just give me a second. I just gotta finish what I was doing. Right, I'm all good. So Anish, you can share your screen, and I'll start your timer as soon as you share your screen. Right, good luck. Yep, I started the timer.
So my name is Tanish Jain. My project is a measure of stress, anxiety, and depression in a familial sample, and I am currently an 8th grader. So today we're going to discuss 4 different sections of my research. First, we have introduction, then we have methods, then we have results, and then finally we have conclusions. So depression, anxiety, and stress are common disorders often seen comorbidly. Depression is mostly categorized as a mood disorder that can give person sadness and a loss of interest in which they usually love, and this usually lasts for at least 2 weeks. Anxiety is a generalized term, and it can refer to a number of disorders, but it's mostly known as generalized anxiety disorder, also known as GAD. GAD represents excessive worriness that are difficult to control and therefore interfere with activities. Stress, on the other hand, is not categorized a disorder as per the DCM. Although depression and anxiety do not have the strongest genetic components compared to a disorder such as schizophrenia or bipolar, studies have found that both tend to run in families, perhaps due to environmental factors, such as COVID-19. So we have 4 objectives. Objective 1 was determine rates of depression in a familial sample. Objective 2 was determine rate of anxiety in a familial sample, and objective 3 was determine rates and stress of a familial sample. And the last one was objective 4, which is demonstrate knowledge of scientific method by conducting research. These were my 4 objectives for my research. So the first 3 were related to the project, and the 4th one was related to the IPARS mission. The depression, anxiety, and stress scale is what I used, and it is most known as DAS-42. A total of 11 participants were included in the survey, with approximately half of them living in India and the other half living in the United States. The scale was converted to a virtual format to accommodate the international sample. I used Google Form because it was the cheapest and fastest option, and it was very easy to use for people that were old, like my aunt and uncle, as well as my grandparents. The DAS42 contains 42 questions with 14 items dedicated to each subscale, and the subscales are depression, anxiety, and stress. The DAS42 contains 42 questions, as we know, and 14 of them are dedicated to depression, stress, and anxiety. Participants were recorded with a 4-point Likert scale. 0 means did not apply to me at all. 1 means it applied to me in some degree or some of the time. 2 means applied to me to a considerate degree or for a good part of time. And 3, lastly, means applied to me a lot or most of the time. Scores were recorded, tallied, and analyzed using the Statistical Package for Social Sciences, also known as SPSS. This table represents the descriptive statistics of my sample. These are the results from my DAS42 survey. A total of 11 participants took the survey, including me. N equals to the number of people. Min equals to the lowest score someone had in their category. Max equals to the highest score someone had in the category. Mean equals to average. SE is standard error, which means the amount of error in the sample. SD equals to standard deviation, which means the amount of variance in the sample. SE shows how much room for error there is. To find that, we do mean plus or minus SE. SD is how spread out the data is, which means the distribution of the data between the min and the max. So for depression, these are the results. For depression, the lowest score was 0, with the highest score being 19. The mean of depression was 5.5, which corresponds to normal levels of depression. For anxiety, the minimum was 1 and the maximum was 18. The mean was also 5.5, which corresponds to normal levels. And thirdly, for stress, the minimum was 0 and the maximum was 22. And the mean was 6.2, which corresponds to normal levels. Also, for depression, 1 participant scored in the mild range and 1 scored in the moderate range. For anxiety, 1 participant scored in the moderate range and 1 scored in the severe range. For stress, 1 participant scored in the mid-level and 1 scored in the moderate. 1 participant was above normal levels for all subscales. Now, when we were looking at this, we also rendered in the fact that this could be because of COVID-19. And I knew that one of my participants was a doctor, and they worked in India with COVID, in the COVID-19 section. And as you know, in India, a lot of bad things have been happening there, especially of how severe it is. So we could also assume that maybe that 1 participant was them, and it was probably because of their job. So the results show that symptoms of anxiety, depression, and stress do occur across the family. These rates can be affected by environmental factors such as the country from which a person lives. The results do show that although genetics do play a major role in these disorders, symptoms can emerge even without a genetic vulnerability. This study highlights the importance of mental health screeners across a family so that vulnerable individuals can receive the necessary support. And as something to protect, when we sent the Google form out to people in India, we made sure to add a chart to say where which hotlines they could call if they ever felt any suicidal thoughts or anxiety, just so they could be safe, right? And lastly, this study shows that symptoms can vary largely even within a family. Thank you. Thank you to the IPARS organization to let me learn more about the STEM routine. Thank you, judges Ritvik and Emily, for listening to my project.
Thank you. That was great. So I guess my first question for you, first of all, congratulations. This was some awesome work. My first question would be, when you were analyzing your data, did you take into account different like geographical differences? Like I know you mentioned that half of your data was from the US and half was from India. And you also mentioned that one of the participants was a doctor. So to what point was that information taken into account when measuring depression and anxiety, et cetera?
So first of all, for the people living in India, and we knew how bad the COVID cases was. So when we looked at the results, we would take them, maybe we would like decrease a point or two from anxiety, depression, and stress because of the fact of COVID-19 and how it's taking extremely big toll on my family. Like a lot of people from my family have died because of it. So and like their like family members have gone to the hospital at times. So that's what we decided to decrease. And for the people living here in America, there was only probably like five of them living here, including me. And my parents also did take this. So I already knew how much stress, anxiety my parents had gotten, right? And I knew that one of my cousins, they lived in Canada. So then sometimes we look at the news just to see how well Canada's doing with the COVID vaccine, right? And we would time on time check up with them just to see how they're doing up there, just so we could add more points to our research just to see how they're doing. And we would do that with the people living in India as well.
So my second question was, you mentioned that you took it as well. So did you factor into age as well? Because that is significant for stress and.
Yeah. I took it as a control, right? Because when I took it, I just decided I put all zeros because I really don't have any stress. I'm an 8th grader in middle school, so like there's barely anything for me, right? And all of our people were over the age of 18. Because as you know, if you're under the age of 18, you're still going through puberty and you have like mood swings every like 1 hour, 2, 3, 4 hours, right? So we don't want that to affect our results because at some point they might be feeling sad for some reason, but at another point they might be feeling happy. So.
And my final question was, you mentioned use of familiar sample size. Do you have any plans or methods that you would use to increase your sample size?
Well, first of all, yeah, I would. I tried to get more people involved in it, but obviously it was up to them and only 11 of them. I think I sent it out to 30 people and only 11 of them did decide to do it. Right. And I had another step of seeing this was I would ask my friends and family, my friends and like their parents to fill this out because I would like to see how much difference we have from like my family and people that I know, just to see like how depression can, anxiety and stress can vary within families and different genetic makeups.
All right. Yeah, so I had a few questions for you too. First of all, I just want to say great job. So my first question for you would be, since you did mention, a lot of these people are related to you or they're people who you know, right? How exactly in the future would you want to avoid this, or is your goal to reach out to other people? Because I think one of the things that's important, especially with these types of projects, is to consider the many biases that might happen. For instance, right? If I were to ask a bunch of, if I put out a survey on the internet and say, oh, you can take it if you want, right? Do you want to take this survey? That creates something called volunteer bias, where volunteers might be more likely to say something than just normal people if you just normally ask them, right? And in this instance, another problem that we do see is, researchers try to skew the data. So let's say I'm part of my own study, I might want to skew the data towards something that I want, right? So that's why the idea of, blinded studies, meaning that or blinded studies where researchers and also sometimes participants don't know what what they're being given.
So when I did send the survey to people, I put full disclaimer, like what it was, how it's gonna work. And I did tell them to put in your feelings in the moment. Don't think that like, oh, I want to help this kid out, so I'm gonna put like some random stuff, right? I did not want that, and I promptly told them to not do that. And then later I did ask them each by text to see if they did do that, and they said no, right? But then I would always try to see, we went back into the Google form, we would try to see if there was like any outliers where people might have done like 3 for no reason, and then they were doing like 1s and 2 zeros and all the other specific parts, right? And also, when I do send this out to other people, I will say that do not do this just to help me out. Do this as a form to see how you're doing personally in life and how your feelings are.
Sure. Okay. Yeah. So what I would recommend in the future is this, right? When you do some these types of projects, the first thing is, like, don't directly, because again, like, you can plant suggestions, right? Like, you don't want to really say anything with respect to like, oh, don't do it for me type of thing. I mean, that's perfectly fine. I get why you're doing that. Another thing is sort of, I think you talked about how you were like decreasing the scores due to COVID, right? I would suggest in with respect to something like that, you'd rather change the focus of your research, maybe the title of your research, to focus on COVID, but you should never edit the data that you're getting from people. And the other thing is, given that you only had 11 people who did your survey, right? I would suggest that, like, yeah, sure, there's things such as outliers, but again, like going through and like just taking out a lot of the data.
We never edited any of them, but we just put them in our mind, like this might have happened because of this. We never edited any of the scores. We just put it in a kind of a mind, as in like we had like a little notebook right on the side, or we would just like say like, oh, we could this might have happened because of this and this and this, but we never edited any of the scores.
Okay. And the last thing I had for you was, you talked about some SPSS for the statistical analysis.
Yeah.
Could you just describe exactly what that does? Or
Okay,
what exactly you're trying to do?
so my mentor, right? He works at a near he works in college. He's in college, and he works in the neuroscience division. So they give them this formatting tool, which basically it has a list of things on what your what like type of form used, right? And we used the DAS42, and we saw if it had the DAS42 form, and it did. So then what it does is it would just complete everything out in a second, take the min, the max, right? The minimum of people, the minimum range of anxiety, right? Which was 0, because the minimum that someone answered, the smallest amount was 0, and the highest you could add when you add it up would be 22, right? So it would just help us things out in making it do faster. And it also finds standard deviation and standard error, which take a very long time to calculate. But all it does is it just does it quickly, because that's like special formulas that a computer can do in a fraction of a second.
All right, thank you so much. Okay, Emily, do you have any other questions?
Yeah, can you just clarify? So you said that you took into account the different locations and the different age ranges, but you didn't change the data. So can you just clarify how you exactly took those into account?
So what we would do is we had a kind of like a little notebook we had, right? And what we would do is we would write stuff to ourselves just to remind us that like this isn't entirely like on a normal circumstance. So like, for example, at one point I wrote, okay, at this moment, the time that this person submitted it, right? The day that this person submitted it, at that time, India was having a bad time. So they could have added some stress to it, but we've never changed anything. That was more just for me to see how, just to see like if certain people in certain parts of India were having different thoughts, because not all my family is gathered in one place in India, right? Like some are in the north, some are in the south. So sometimes I would notice that people in the north at points were having higher numbers than people in the south at some points.
Okay, thank you. So you qualified. I understand. I was thinking in the future it'd be important to take in consideration present data, not trying to compare it to something that would have happened last year.
Yeah. Yeah, but yeah.
I understand what you're going for. I understand.
Yeah.
All right. I think we're honest. We're out of time. Our 8 minutes are up anyway. So sorry if anyone in the public wanted to ask questions. We've got to keep moving. So thank you so much, Tanya, for your presentation. I'm going to remove you from spotlight. If you could please mute yourself.
Thank you.
And our next presenter is going to be Charlie's. So if you'd like to, turn on your camera, unmute yourself and give me and Emily, because Emily and I are the judges again. So if you give us a minute, then we can get started. I'll let you know when we're ready.
I'm good when you are, Vic.
Hi, my name is Charlize. I am currently a 5th grader and my project focuses on comparing trends in oral hygiene and the development of periodontal disease. Periodontal disease is a main part of my project, and to give the gist of what exactly periodontal disease is, it's an oral disease that affects over 3 million people in the United States yearly. Specifically, what this disease does is damage the soft tissue that supports the teeth, and the risk factors that make you more susceptible to periodontal disease include smoking, drinking, chronic diseases, and poor oral hygiene. However, it should be taken into account that factors age, race, sex, levels of education, levels of poverty, and genetics can also be a factor. In terms of age, older people are at higher risk, and in terms of sex, men are more susceptible. As said earlier, genetics can be a risk factor for periodontal disease. And according to heritability studies, 38 to 82% of the population that has periodontitis, the advanced stage of periodontal disease, may have some relation to a genetic factor. Some of the polymorphisms that relate to the risk of developing periodontitis include interleukin-1 alpha, 1 beta, interleukin-6, 10, matrix metalloproteinase 3, shown in the figure below, and matrix metalloproteinase 9. Currently, we don't know which demographics most of the genes are specific to. Additionally, age also has a relation to periodontal disease. Periodontal disease can affect anyone in any stage of their life. However, as age increases, the chances of developing periodontal disease increases as well. You can see this in the figure below from the CDC that represents the prevalence of periodontitis in adults of various ages. To explain this increased age as we get older, the nerves in the root lose sensitivity. Therefore, a cavity or problem in your mouth could become so severe and you could not notice any of the pain. So by the time you realize it has become too severe to treat without serious procedures like extraction. Also, the gum tissues recede with age, and because of that, the tissue of the soft root becomes bare, leading to more problems like periodontal disease. And usually, symptoms of periodontal disease do not show until people are in their 30s or 40s. Another main part of my project is oral hygiene. And to summarize the idea of oral hygiene, it's healthy habits which are there to keep the entire mouth healthy and clean so that we have lower susceptibility to periodontal disease. According to Mayo Clinic, healthy oral hygiene includes brushing teeth twice a day, daily flossing, no use of any tobacco products, and limited alcoholic drinks. So after taking into account what factors contribute to people getting periodontal disease, I asked the question of, are kinds of people who have worse oral hygiene also developing periodontal disease? My hypothesis of this project is if oral hygiene significantly contributes to whether a person will develop periodontal disease, the trends seen in who has periodontal disease and who has poor oral hygiene should be similar. In this project, we conducted an oral hygiene survey, collecting responses of people of different demographics, specifically age, race, and sex. We asked questions that would reveal how they take care of their teeth, including both oral habits and lifestyle. We also asked other questions to build the subject's profile in terms of if oral problems already run in their family. So based off of the questions we asked and how important the idea of answering yes or no was, we created a point system to see the trends in different demographics. The more points the subject has, the more it would mean that they have good and healthy oral hygiene habits. The highest score a subject can get is 17. With the points collected, we then created graphs to look at the differences in males versus females oral hygiene. And within each group, we looked at age. Some things to note are that the men had a higher average score, specifically between the ages of 61 to 80. The highest scores in females were between the ages of 21 to 40. To look at the trends in different races, we again collected the points and made a graph. Overall, Asians or Pacific Islander and Hispanic or Latinos had the high average of 9.9, and the lowest was in the Black or African American race at 7.4. To summarize the results, men had lower results in age groups 0 to 20, 21 to 40, and 41 to 60 than women did. Yet in the age group 61 to 80, women had lower results than men did. Moving on to the trends in different races, Asian or Pacific Islander and Hispanic or Latino races had the highest results at 9.9 points, while Caucasian was at 9.4 and Black or African American at 7.4 points. Based on the results we got from the oral hygiene survey, we can now look at the factor genetics on why one demographic had higher rates of periodontal disease, yet highest results for oral hygiene. One demographic which falls into that group is Hispanics or Latinos. The gene NAMPT plays a vital role in periodontal disease, which is regulating inflammation mediators. And what's more is that this gene is present in Latinos, yet rare in the European, Asian, and Southeast Asian ancestry. However, even though our data supports the claim, which is that the Asian race were found to have one of the lowest rates of periodontal disease, the Asian race does actually have a promoter gene polymorphism, which is significantly found in the Chinese population. The promoter gene polymorphism is matrix metalloproteinase 1. I have a hypothesis that it is because matrix metalloproteinase 1 is so specific to the Han nationality. That is the reason why the Asian race still has one of the lowest rates of periodontal disease. However, this is not confirmed and of course is still up for discussion. My conclusion of this project is that neither oral hygiene nor genetics play a more dominant role in preventing the development of periodontal disease. If this project was to continue, I would further investigate some social factors that could affect the rate of periodontal disease, such as surveying people of different socioeconomic statuses, education, use of dental services, also current health status, and more diverse geographic regions. Survey because the survey only reached people in Seattle, Washington, Kentucky, New York, and Malaysia. And now that we know that genes NAMPT and matrix metalloproteinase 1 lead to the increased risk of periodontal disease, I would also like to investigate the research of the mechanisms behind how this happens. Here are my references that I used in this project. Thank you to all the people who filled out my survey, my mentor, Sharon Lee, and IPARS for providing me this experience in creating this research project. Thank you for your time and attention. At this time, I'd be happy to answer any questions.
Hi, Charlize. Great presentation. I really enjoyed it. So my first question for you is, if you could go back to, if you want to share your screen again and then go back to the survey itself. I just have a few questions like before the results. So essentially, my first question is, so how many people actually responded to your survey?
130.
Oh, wow, that's a lot. Nice job. So could you go to the summary of the results for a second, the graph? Yeah. Like the graph rather than like the thank you. Let me just take a look. Yeah, so I saw, like, did you consider it based on different races when you were going to your conclusion too, and like what did you get out of that? Because I know at the end you had a conclusion, right? So so my question really is like based on different races, what can we sort of conclude, or what can we like conclude from this data?
So based on the data that I got, I created a graph, and from there I could really look into the genetics and find out why this race has high rates of periodontal disease yet has good oral hygiene.
Okay, yeah, that makes sense. Yeah, my only other question is, yeah, could you really talk about how how exactly did you come to get the questions that how did you develop the questions that you asked the people in the survey, right? And then how exactly did you send it out?
So I wanted to find out about the subjects' oral hygiene habits and sort of their profile and family history. And so mainly I just sent the survey out to my friends and family, my teacher, and my classmates, and my mentor did the same. And so we just asked them to share it out to people. And because my parents actually have a lot of friends in Malaysia, and so that's how we got a lot of responses.
Great, thank you so much. Yeah, this is a very nice project. I really enjoyed, and I'm really proud of you for doing this much.
Yeah, congratulations. This is an awesome accomplishment. I guess my question would be, based on your data, you talked a little bit about looking into the genetics. What would your next steps be for the project?
So going back to the future directions, I would really just want to look into the mechanisms behind how the genes relate to periodontal disease, like what it exactly does, which makes it easier for people to get periodontal disease.
Is that it, Emily? Do you have any other questions?
I don't. Do you want to open up to the public again?
Yep, public or anyone, if you guys have questions you wanted to ask Charlie's. All right, well, I don't think anyone seems to have any questions. So what I'm thinking is, yeah, so thank you so much for your presentation. I'm going to remove the spotlight from you. Very nice job. And what we're going to do is, if you could mute yourself, we're going to move on to the next person. All right, so the next person will be Anika. So if you could, is she here? Don't think she's here, is she? Anika, are you here? Yeah, I don't think she's here, guys. So what we'll do is we'll skip her for now. If she shows up, we might do it at the end. But for now, we will skip over Anika. And we'll move on to our next presenter, who will be Anshi. So Anshi, if you could just give me a second, because I've just got to finish up Charlie's rubric, then we will get started as soon as I've finished that, all right? So if you could just get ready with your presentation, etc., then we will be able to get started. Let me just spotlight for a second.
Can I start?
Yeah, just give me like 20 seconds. I'm just trying to finish up your rubric, and then we can get started. All right, yeah, you can go ahead now.
Okay, so hi, my name is Ansha Gawal and I'm 13 years old, and my project is on human behavior towards global warming. And so I chose this topic because I've always been very interested on like how the brain reacts to like different situations, and I'm also very passionate about the environment and environmental issues. So I thought of testing how the brain reacts to like environmental issues like global warming. So my question is, if people claim that global warming is a major issue, do they actually act to slow it down? My hypothesis was that they don't actually slow it down because global warming does not have an immediate effect, but rather occurs over time. So they don't really people won't pay much attention to it. So through my research, I learned a lot about global warming and human behavior. I'm going to be briefly discussing that right now. So firstly, I found a lot of statistical evidence for global warming. And I also learned that the greenhouse effect is when solar radiations hit the Earth and bounce back, but the greenhouse gases trap the solar radiation, which prevents it from escaping. This causes the Earth's atmosphere to heat up since all the absorbed energy is captured. The primary greenhouse gases are water vapor, carbon dioxide, methane, ozone, and nitrous oxide. These greenhouse gases are released into the atmosphere through human activities, such as burning fossil fuels. So not only does global warming heat up the Earth, but it also has a lot of other effects, such as it causes sea levels to rise rapidly. And the rising sea levels has also caused a lot of low-lying coastal areas to flood. Global warming also has other effects on animals, such as if animals don't adapt to their changing environment quick enough, they will die out. So I also researched some possible solutions for global warming. I found out that planting trees, using energy efficient ways to travel, limiting air conditioning use, and cutting down on the meat we eat, and powering our houses with renewable energies are all ways that we could prevent that, or that could be used to prevent global warming. So there's so many things we could do. Why don't we do them so there's no more global warming? To figure this out, I researched something called the pain theory proposed by Harvard psychologist Daniel Gilbert. PAIN stands for personal, abrupt, immoral, and now. These are the 4 key things which trigger us to react to a problem. Personal meaning something that we feel connected to and we think is directly related to us. Since global warming does not have a direct impact on us, we don't pay much attention to it. Abrupt meaning, since it doesn't have an immediate effect, we don't pay much attention to it because our brain doesn't detect it because it's not something that's very detectable and noticeable. Immoral meaning it doesn't like violate our moral intuitions, and we don't think it like directly harms somebody. So again, we don't pay much attention to it. And lastly, now meaning since it's something that would have like major consequences in the future, we pay less attention to it since we are more focused on the present compared to the future. So I also researched humans' priorities, and I found out that families, friends, health, work, and crime are all at the top of the priority list and compared to global warming. So for this experiment, I created a Google form and asked a bunch of test subjects to fill it out. My Google form tested 2 things. It tested how much people think they do to stop global warming and how much they really do to stop global warming. So these questions here and here showed me how much they think they do. So for example, the first question here says, how fearful are you about global warming impacting your future? And so this helped me know that how much they think it affects them because they're more likely to work towards something that affects them more. And these questions here helped me evaluate how much they really do to prevent global warming because they simply asked whether or not they did something such as plant trees. So to evaluate my data, I made like a whole point system. And so for the first half of the questions, option 1 would have the most points and the last option would have the least points. So this helped me percentage my data and figure out how much people actually did and how much people think they did. So my data showed that the percentage for how much people think they do is 80%, and what they really do is 34%. So this is a huge difference between the 2. So for my graph, so this is my first graph, and this basically shows that all my test subjects did agree that global warming is a major issue. And this was important to me because it helped me know that all my test subjects agreed that global warming is real, and I knew that this would not be one of the factors that would affect my data. This graph here shows how much they think global warming affects them. And you can see how all the bars here are pretty high, and the lowest it goes to is about 70%. And this is what they really do. And all the bars here are relatively low, and there are even some at 0. So my conclusion was that the difference between what people think they do and what they really do is very drastic. And this shows that my hypothesis was proven because people don't do much to prevent global warming. And I think this is because since global warming doesn't personally affect them, it's not going to be something that they're going to be thinking about constantly, or it's more likely something that they're not going to think about regularly, or like they're going to forget about often. So they don't pay much attention to it. So in this experiment, I also had a few limitations, such as the number of test subjects I could gather. I only got a small group of people to participate in my experiment. This experiment was really important because it helped me realize that people aren't doing a lot to prevent global warming. If things continue this way, one day our world will have really intense climate patterns that humans probably will not be able to survive. So I think to prevent this, we could try reminding people how to stop global warming by making signs and cartoons that could be printed on daily use items. This could help gain people's attention and make them act towards it, because currently people aren't paying much attention to it because they have like other priorities. For example, if we start printing signs on daily use items like this one over here, it could help remind people about global warming. So this is a sign I stuck on a milk carton for recycling, because recycling reduces energy consumption, which leads to less global warming. And I know a lot of products already have little recycling signs, but we could even try to like get like little cartoons which show the consequences of global warming, which would help people realize how bad it can be. And I'm confident that it would help change their actions, and I'm pretty sure they would act towards it and actually try to prevent it. So these are all the sources I used throughout my project. And lastly, I want to thank all my test subjects who helped me throughout this project, and they have been very cooperative, and also my mentor, Ava, who has helped me immensely. Does anybody have any questions?
All right, so I have a few questions for you. My first question is regarding your collection of data, right? See, if you could you go back to your slides, and if you want to go back to the actual questions you were asking people. So since it's fine. All right, so since you were asking people about so you were trying to understand, like, you know, do they think it's an issue when you ask them directly, which obviously most people would, right? Versus like, do they really feel it's an issue, right? That's what you were trying to delineate, right? So one of the things that I would like you to consider with respect to this is that think about it, right? If I were to even using yours as an example, right? If you say if you ask them a question like global warming is a major issue, and then you ask them questions such as like, are these the questions that like so first things first, which questions did you use to delineate between the two?
So these were the questions that like helped me know like how much like they think it affects them, and hold on. So these are also part of those that part, and then these are the 5 questions that helped me know what they actually do.
Okay, yeah. So the first thing is this, like, if you want to go back to the first part, so if I'm asking you questions like, oh, global warming is a real issue, right, and stuff like that, and then right after that, I ask you all the other questions, right? You're more likely to answer favorably for those, okay? In my opinion, because like, let's say if I make you conscious about something, right, then I ask you questions related to what I just made you conscious about, there's a higher probability that you're going to be skewed towards whatever that is. In this case, it's that global warming is bad because you already brought that to their attention, right? So one of the things I might suggest is, when you're doing this, randomly select 2 two different types of people, right? So like essentially create two separate, so like 10 people here, 10 people here. They're random, not the same people, okay? So independent. And then what you do is some of those 10 people, you'd ask them the first questions. The other 10 people, you ask them the second questions, right? Because we don't want any confounding or like bias where essentially the previous questions can actually impact their answers on the next questions. Does that make sense?
Yeah.
And another thing I would say is, yeah, like regarding your survey, how many people did you get to respond? Or how many subjects do you have?
I only got about 20.
Okay, that's a solid number. Okay, yeah, I mean that's really the question I have. Raga, do you have any questions?
Yes. So, overall, good job. Congrats to finishing this journey. So I had a quick question about how you would account in for different demographics. So, for example, it's seen that Gen Z people tend to talk more about global warming and address this problem since they grew up with this problem, whereas other generations may not have thought about this problem as much as they grew up in a normal environment. So how will you ensure there's a variety of people answering this, filling out this survey, and how will you take this into account, I guess?
Okay, so currently, in this project, I've only used all my test subjects were either middle schoolers, high schoolers, so I didn't really have anybody else besides Gen Z. But if I would if I were to expand on this project and try to include more people and everything, I would probably try to take in different age groups and everything. But for this one, I couldn't really gather many people up.
Yeah, so how would you ensure that that wouldn't have much of an effect on the questions you're asking or on your project in general?
Wait, sorry, could you repeat that?
So basically, you know how there's the different generational gaps. You said that you only asked middle schoolers and high schoolers. So if you, for say, go and ask a parent to take it, how is there a way you would keep track of maybe so I guess this would be referencing maybe a future project you could do is see using a similar using your same form, you could maybe send it out to some older generations, to some Gen Z people, and then you could see maybe the difference and see how this problem has been taken into account by these two different generations. That would just be maybe a suggestion for a future experiment you could do.
Okay.
All right, does the public have any other questions for Anshi?
Yeah, so I was actually wondering where your participants were from, if they're from here or a different country.
Yeah, they're all from America. Yeah.
Okay. And also, did you take into consideration the how much someone was educated? Because I feel like people who are highly educated might have a different opinion, whereas if someone didn't go to school, they would have a different opinion.
Well, so all my test subjects were going to school and everything, and I would say there wasn't a huge age gap. They were all pretty much around the same age, so I feel like that wouldn't be a factor that would really affect my data too much.
Okay, other questions, guys? Okay, so I'm going to remove you from the spotlight. So what the plan is now is we're actually going to take, since we are a little ahead of schedule, we will be taking maybe a 15-minute break. And during this 15-minute break, essentially what will happen is us judges will really be finishing out our rubrics and our comments for the people who have already gone. And what we really want from you guys is, since Jacob was asking, if anyone has any other questions they wanted to ask a specific presenter, if you guys wanted to, talk about some presentation you found good or any question you had, right? things like that. Now is the time to sort of do that. So, I mean, if anyone wants to get us started off, Jacob, if you had any questions or if you guys wanted to talk about a specific topic related to IPARS science, anything. But before we do go, I just wanted to say up till now, everyone has been doing a very good job, and we can clearly see you guys are well prepared. You guys have, a lot of you guys have nailed, the scientific method, the way you're going through this. It's a very good story for a lot of you guys, how you got from the idea, from your question, right, all the way to these like pretty deep projects, which is really, really interesting and great for us as judges to hear about. Yeah, so if you guys wanted to talk about anything, then now's the time.
I wanted to ask some of the other just mentees or mentors kind of how did you guys go about finding your research topic or the area you were interested in? I mean, for a lot of us, at least for me as a mentor, I have a pretty specific area of expertise, and I guess for everyone who is younger, I wanted to know what interested in you in like one field or the other, medicine or like engineering and things like that.
Well, I guess I'll start us off. For me, in the beginning, I wasn't really like, interested in chemistry. I was like more interested in biology. So my mentor and I explored like fields, and it took me over like 5 weeks to actually find my project. And we kind of just like we didn't really went for it, and so we just explored different things each week. And when something didn't work out, we would just like find something else I was interested in, like a specific article. So my like path to my project was kind of abstract, but essentially, like I guess the very beginnings of my project was from learning about corrosion. But yeah.
I can go second. So I got into the dentistry field because since I was young, I really liked dentistry, and I thought it was really interesting. And ever since then, I've always wanted to become a dentist. And because periodontal disease is such a big problem, I wanted my project to involve periodontal disease.
That's very cool. My girlfriend right now is actually going to be going to dental school at UCLA next year. Dentistry is a cool career. And then let's see, how has the pandemic affected some of these projects? Is there anything that you guys would have liked to do for your project or to continue the project you have now if you could do things more in person?
Well, for me, there wasn't like really much of a difference because my project was like pretty much remote and it didn't really involve anyone. But definitely like some of my original ideas, I would have like liked to do it in person with someone else, like with my friends or something. But
I'm going to go take a break for a second and get something to drink.
All right, guys. So let's get back. I think most of us have had a chance to go through and finish our rubrics. So if everyone could turn your cameras back on. I hope you guys had a little bit of time to talk to each other. And the next person who will be going is Akshika. So if you can turn on your camera, unmute yourself, but give me a second here. I'll need to spotlight you, and then let me just make sure that everything is ready here before you go ahead. Okay, so if Yash and Kevin, are you guys ready?
I'm ready.
Yeah.
Okay, hi. Is my audio all right?
Yes, we can hear your audio, but do you want to share your screen or?
Yeah, I was just making sure my audio was working.
Sure, sure.
Am I all right to get started now?
Yep, I think everyone is ready, so you can get started.
Okay. Hi, my name is Akshika Chawade, and I'm currently a junior at Braintree High School in Massachusetts. Today, I'll be presenting my research regarding the reduction of carbon dioxide emissions in the Indian textile industry through the usage of rechargeable batteries. Almost all batteries are divided into two parts: the cathode with a positive charge and the anode with a negative charge. Electrons in the anode are attracted to the cathode and begin to travel in that direction, flowing from one electrode to another. This flow and shift in charge generates electrical energy that is then used to power a multitude of items. whether it be a small toy truck or massive industrial machines. Non-rechargeable batteries only have one life cycle, which is the maximum number of chemical reactions that can occur in a battery. Meanwhile, rechargeable batteries can have multiple life cycles, as its ions can be reset after every cycle. This means that one battery can be used for a significantly longer period of time as compared to a non-rechargeable one. One rechargeable battery can replace up to 100 non-rechargeable ones. Not only is this more convenient and cheaper in the long run for users, it also conserves materials and resources. Now it's time to take a look at the problem I'm targeting today. From a broad perspective, the textile industry is the second most polluting industry in the world, with carbon emissions of 1.7 billion tons per year. It contributes to 10% of all global emissions, and factors like the usage of coal and various chemicals, demands of fast fashion, and overproduction contribute to air pollution. 60% of all textile products are manufactured in China and India. In fact, one of the top 3 clothing manufacturing companies is based in India. When I last visited my mother country, India, in 2018, it was nearly impossible to travel in certain communities without a nose covering to avoid inhaling harmful pollutants. For the unfortunate without access to hygienic resources, this massive amount of air pollution is quite inexcusable and simply inhumane. Change is necessary, and it must start with the textile industry. The textile industry is invaluable to India's economy, as 14% of its entire workforce is involved in textiles. 4% of India's GDP is dependent on this industry, and 11% of all global mercantile exports originate from India. Over 4,000 factories are sprinkled across the Indian subcontinent in both urban and rural locations. In urban locations, most factories depend on electricity generated from city power plants to power their machinery, meaning that the demand for fossil fuels is quite low. On the other hand, countless rural factories depend on fossil fuels and coal due to limited funding for infrastructure development and little access to electricity. It is important to note, however, that although the aforementioned power plants generate energy through fossil fuels, the factories themselves are not directly using them, which is why I am focusing on rural factories today. The continued usage of environmentally unsafe machinery, such as steam boilers, thermal packs, and diesel generators, results in harmful pollutants like nitrous oxide and carbon dioxide. Nitrous oxide, a byproduct of synthetic fiber production, is more toxic than CO2 because it has 300 times more potentiality to harm the stratospheric layer than CO2. As there are thousands of textile factories in India who emit large quantities of these pollutants, the condition of the atmosphere is rapidly deteriorating, and immediate action is necessary to slow down this progression. Now it's time to take a look at one of the most polluting machines in a textile factory, an industrial steam boiler. Its function is to generate enough heat to boil water to create large amounts of steam. Its purpose requires it to consume up to 48% of all energy in a factory. Its fuel system, or the components that convert the energy from fossil fuels into electricity, uses approximately 50 megawatts per year, enough to easily power at least 33,000 homes for a year. One single steam boiler uses an average of 6 tons of coal per year to produce this energy. Since a ton of coal creates more than 4,000 pounds of CO2 when it is burned, we see that 6 tons release more than 25,000 pounds of CO2 into the atmosphere. This is just from one steam boiler every single day. As most factories have at least 2 boilers, fossil fuel consumption and pollution rates are far too high. One plausible, environmentally friendly replacement for the usage of fossil fuels are rechargeable batteries. The 3 main types of rechargeable batteries are nickel metal hydride, nickel cadmium, and lithium ion. NIMH batteries have the ability to recharge quickly. However, they only have up to 600 life cycles, and since NIMH batteries go through each life cycle quite quickly, they cannot last for more than a year. NICD batteries were also eliminated as a possible solution because cadmium can be very toxic in large quantities and is very likely to worsen safety conditions for workers. This allowed me to conclude that lithium-ion batteries are the best option as they have increased power holding capabilities and are significantly lighter and easier to use. However, there are multiple types of lithium-ion batteries that each have different strengths and weaknesses. This meant that I had to determine the appropriate requirements for a specific lithium-ion battery needed to meet the purposes of powering an industrial steam boiler. Load capacity refers to the maximum amount of work and energy a battery can offer in a given amount of time. Having a capacity of at least 24 milliamp hours would mean that the battery can adapt to heavy energy consumption machines. Thermal stability is the ability to resist decomposing under a certain temperature. As the boiling point of water is 212 degrees Fahrenheit, the battery must be able to handle temperatures of at least 190 degrees. Specific energy, which is the energy storage density of a battery and determines the level of heavy-duty tasks it can handle, must be anywhere from 275 to 310 watt-hour per kilogram. To ensure that underfunded rural factories can obtain these batteries, the cost should fall in between $320 to $390 per watt-hour per gram, and it must be easily accessible. Finally, to reduce the number of restocking trips made by a factory, it must have at least 1,000 life cycles. Setting my requirements then led me to analyze the various types of lithium-ion batteries currently available. Here's a table summarizing the information I gathered about 5 different types of lithium-ion batteries. This allowed me to determine which batteries are not compatible with the solution I was searching for. For example, I could immediately eliminate lithium cobalt batteries as its thermal stability is only 150, as opposed to the 190 degrees that I was looking for. This would mean that lithium cobalt would not be suitable for my purposes. The highlighted row shows that lithium nickel manganese cobalt oxide batteries, or NMC batteries for short, are the best fit for the purposes of powering steam boilers. Its pros far outweigh the cons. NMC batteries can last up to 3 years, allowing the conservation of resources and reducing the number of necessary restocking trips. It can handle the load capacity of a boiler and surpasses the thermal stability requirement. NMC batteries can efficiently power and keep up with the demands of a boiler. The few disadvantages include a lower specific energy that will not interfere too much with the functions of a boiler. Although they are harder to obtain and more expensive, the fact that they only need to be replaced once every 3 years means that obtaining NMCs will not be a regular, tedious task. Additionally, since research is ongoing to improve these batteries, it is likely that there will be easy access and lower costs in the future. As for recharging these batteries, this is a simple task that can be performed by any factory worker with simple instructions. They simply require a voltage limiting device. On the left, you will see a small device that contains the circuitry shown on the right. With a flow of 4.2 volts per cell or per battery, a single battery can be fully recharged in about an hour. Note that users will need to be cautious of limiting the voltage. If the voltage is too high, it is possible that the battery will become overcharged, causing the battery to be plated with metallic lithium, be oxidized, lose its stability, and begin producing CO2. To incorporate these batteries as a part of a steam boiler, the current components of the fuel system, which include a smoke box, firebox, and chimney, must be replaced with an electrical box. The average electrical box takes up 3.6 meters cubed, as opposed to the fuel system taking up 21.1 meters cubed. Implementing an electrical box would reduce the volume occupied by a steam boiler. Freeing up almost 17.5 meters cubed per machine can allow factories to invest in other machinery and thus increase their revenue. Here you will see the schematics of the fossil fuel components of a steam boiler and the proposed electrical box. Not only will the electrical box be fully effective for the purposes of powering a steam boiler, it is also significantly safer for workers who handle such heavy machinery. This solution also meets regulations set by the Indian government. The only existing legislation that manages industrial steam boilers is the Indian Boiler Regulations, passed in 1950, and have amendments up till 2005. They have few regulations as most Indian textile factories are situated in rural locations with limited resources. However, since there are high levels of air pollution, the Indian government looks favorably upon an environmentally sustainable alternative that would both reduce harmful emissions and help underfunded factories make more revenue in the long run, like the electrical box. Taking a small case study of ethnic textiles, a family-owned business for more than 30 years, this solution would greatly benefit them. As most of their workers have been working for the business for years, this business has deep ties to its community and takes pride in their ability to give back. By reducing the amount of money spent towards purchasing energy sources through the implementation of an electrical box, the business could increase the incomes of their workers. As of now, countless research projects are taking place around the world to determine the best elements suitable for a more energy efficient, long-lasting, and cheap rechargeable battery. These experiments are not limited to lithium-ion batteries, and it is possible that a better alternative may be found. For example, LMC Automotive, a company that conducts research for the automotive market industry, has been optimistic about the growth and development of lithium-ion batteries. As of 2019, they predicted that the capacity of lithium-ion batteries will continue to increase by around 7% annually, and are constantly working to create the most efficient rechargeable battery possible. In conclusion, even though I found NMC batteries to be the most prospective solution in the short term for the Indian textile industry, rapidly advancing research could one day provide a more efficient battery for factories all around the world. This is the end of my project and work thus far. Here are some of the resources I used during this project. Thank you for listening, and please ask any questions you may have. Thank you.
Hey, Akshika, congratulations on a really nice project. I really liked it, especially the animation in the beginning, like electrolysis. I had a question. So you're looking into NMC batteries, but the cathodes are relatively new, but they do suffer from instabilities just by the crystalline structures, and they have passivation instabilities as well, so they fade away. And considering you're talking about a country like India that is still developing, how do you expect India to sustain the use of these batteries that have still to be researched a lot?
As with any technology, nothing is truly a perfect solution. Even in NMC batteries, there were some faults that I found, but since research is currently going on, it is possible that we might have a better version of a more stable NMC battery in the future. So optimistically, I believe that this problem can be easily solved in the future.
Yeah, if you ever do look into this a bit more, look into phosphine graphene hybrid materials for electrodes. Those might interest you. And another question about the voltage limitation you were talking about. So lithium-ion batteries that we have in our phones, computers, they have discharge current, so they're always kind of running to prevent this your phone battery from like destroying itself if you overcharge it. Do NMCs have the same technology currently? You talked about a limitation of the voltage, but do they have a discharge current?
As of now, most voltage limiting devices do not have that capability, which is why it's important for factory workers to be cautious of this as they're recharging the batteries. It is one of the flaws as of now, but with ongoing research, this can also be easily fixed.
All right, great.
Ashika, thank you so much for presenting. I really like your project. And I also have a few questions about your requirements for choosing the batteries. Can you go back to that slide? Can you kind of explain how did you arrive at these numbers and ranges? For example, the specific heat and the cost. How did you arrive this range of numbers?
By specific heat, are you referring to specific energy? Or
oh, I'm sorry. I mean the specific energy.
Okay, so since these numbers were not readily available in an article, I had to go through websites like Alibaba and take a look at steam boilers that are currently on the market today. take a look at that company's products, and kind of take a look at the product descriptions to find the details I needed. Since there are differences in the data of each steam boiler, I did have to average out some of my calculations. As for load capacity, I used the same method. There wasn't a specific number that was readily available in an article, so I had to go through about 10 different steam boilers to come up with the average, with an average from the data I was planning on using during my research.
Okay. And do you consider what aspects of this project do you think you can improve?
I think perhaps having more access to seeing a steam boiler perhaps in real life, and maybe talking to the engineers behind the creation of steam boilers would truly be a really helpful experience in improving my research, as it would give me more firsthand knowledge on how a steam boiler is created, how it functions, and how exactly it draws power.
Thank you.
Thank you.
All right. So now, if anyone from the public has questions.
Hi. Well, first of all, really great talk. I think this is, really, I liked how specific this project was, and how feasible your talk made it sound. I guess as a small follow up to the last question, I just wanted to ask about the specific energy again. Because like you said, the battery you found didn't meet that requirement, but that should be okay, right? That just means it'll be heavier than expected.
Right. It would mean that it would require more batteries, as opposed to taking something that did meet the requirements, such as something like NCA, which is pretty low, but it's close enough to what we're looking for. It would just mean that we would require more NMCs compared to NCAs, for example.
Okay. Yeah. And then I guess the second question was a bit broader. So of course, the use of batteries would shift the energy or the energy source to electricity. I just wanted to ask kind of what kinds of energy infrastructure in India, and specifically clean energy, if that's what we're looking for, like solar or wind or nuclear, would be needed to provide that electricity to the energy grid to charge all these batteries.
So currently in India, they are still dependent on fossil fuels, including coal, and they burn a lot of these fossil fuels to actually generate the massive amounts of power needed in urban cities, especially. Currently, the government is looking into different green alternatives to producing energy. I know solar panels is a project that is really coming alive in cities like Bangalore and a couple of parts in Bombay or Mumbai. But given the high population of India, a lot of the funding usually ends up going towards relief programs for the poor. And especially during COVID, India is not in such a great situation right now, and it has really been focusing most of its funds towards trying to help people medically and socially. So the focus has kind of shifted off as of now. I hope that kind of answered your question.
Yes, that's great. Thank you.
All right. Any other quick questions? Okay. Thanks for your presentation, Afrika. And I'm going to now remove your spotlight. If you could stop sharing your screen. Okay, thank you. And if you could just mute yourself. Yep. Okay. So our final presenter will be Atreya. So you want to turn on your camera. And give Emily a second. If she's ready, then we can get started.
I'm ready. You can start.
Okay. Give me a second to just put it in spotlight. Okay, and if you can share your screen.
Yeah. So can everyone see that?
Yeah.
Okay. So hello everyone. My name is Atreya Milana, and I'm an 8th grader who goes to William Diamond Middle School in Lexington, Massachusetts. And my experiment was about the effect of activities on memory loss, specifically short-term memory loss. So first of all, I would just like to start on why did I pick this topic? What made me interested? So I was kind of interested in how the brain works, how kind of such a small part in relation to how big our body is can basically like dictate how our entire body functions on a daily basis. And I didn't have the resources to conduct an elaborate or a research heavy based experiment, for example, in a lab. So I wanted to choose a simple yet impactful topic that I could experiment about. And many people in the world suffer from short-term memory loss, which can actually lead to more severe implications, as I will explain later in my presentation. So I wanted to find the common activity that contributes the most to this phenomenon. And yeah, as I said before, this event occurs daily to many people around the world and can lead to several negative implications. And throughout my experiment, I hope to pinpoint an area of activity that contributes to the most short-term memory loss. So some background info. Short-term memory loss is mainly caused by distractions, and distractions are phenomena that prevent one from giving their full attention to another thing, almost like a blocking system. And these distractions trick people's brains into falling for short-term rewards, which can lead to negative results in the long run. And getting more technical here, the reward or mesolimbic pathway are a series of parts in the brain that contribute to distraction and more specifically addiction. And many people associate addiction with severe things such as a smoking addiction or a drug addiction. And an important part of this pathway is the ventral tegmental area, which is often abbreviated as a VTA. And the VTA is basically a cluster of neurons in the middle part of the brain. And the main function of the VTA is to release dopamine, which is a neurotransmitter that contributes to happiness, and excessive amounts of dopamine can actually lead to addiction and distraction. And these neurons then stretch to an area called the striatum, which receives those neurotransmitters such as dopamine and then turns the signals into human body functions, such as grabbing a certain type of sugary food, since many people like and often overconsume sugary foods, or moving a specific body part in order to achieve something. Next up, we have the nucleus accumbens, which actually contributes to motivation and rewarding as well. And the olfactory tubercle, which plays a large part in the smelling part of the pathway. As many of you might know, sensory feelings actually contribute a large part to what we do in daily life, and hence contributes to a large part of addiction and distraction. So since we know about distraction now, I would like to transfer over to memory and how distraction basically affects memory. And memory helps one make critical connections and remember important informations, as well as defining moments in one's life. And memory is registered in the brain through another pathway called the limbic system. And each part of the system has its own unique role, helping us memorize information and remember moments. And the main memory related part of this system is the amygdala, which is a small circular shaped organ that helps us convey and remember emotional memories and connect them to different parts in our life. And another critical part of the limbic system is the hippocampus, which actually helps convert important aspects of our life from short-term memory to long-term memory, and essentially embedding it in one's mind. And when people have short-term memory loss, it's mainly due to the hippocampus getting affected or distracted by other distractions. And there are also several other organs and parts that basically supplement this memory internalization. But these are some of the important ones that I was focusing on in order to conduct my experiment. So my experimental design, and I've talked about the purpose, was to determine which common activity contributes to the most short-term memory loss in people. And I hypothesized that if the participant plays a computer game online or does something online, then it will cause the most memory deterioration of all the activities. And my procedure is I had 12 participants who were aged 13 to 16. And I created a photo collage. And just before I get into my procedure, I would like to mention that I did all of this presentation online on Zoom. And I created a photo collage and basically let the participants see it, memorize some of the important features for 1 minute. And immediately after they looked at the photo collage, they took a Google form with 5 questions based on the photo collage, what some of the important features. And then I actually made the participants do one of the 4 activities that I had. So I split them into actually 5 separate breakout rooms. And the 4 activities that I actually made them do, each person did one. It was reading a book or reading an article, drawing, talking with other participants online, or playing a computer game. And the 5th group was a control group who actually did nothing. And each person, based on their allotted activity, did their activity for 5 minutes. And yeah, that included the control group who actually did nothing during the 5 minutes. And after the participants did their activity for 5 minutes, they returned to the main room as they were doing these activities in the breakout rooms of Zoom. And they completed another Google form about the same photo collage, but with different questions. And then this was not exactly related to the results of my experiment, but they took a reflection form, basically analyzing how they felt before and after their assigned activities and during the experiment. So basically, I think I explained this earlier, but some of the materials, depending on the activity, was a computer, a random book, a piece of paper, and a pencil/pen for drawing, and 12 participants aged 13 to 16. Here were some of the results. We actually gave each of the participants a letter to identify them, to keep it anonymous and not intrusive. And this shows the amount of questions they got before the activity and after the activity on both of the forms. And this also shows the participant and the percent change in their scores between each activity. Moving on, this is basically a pictorial representation of the scores of each person before and after their activity, and the average percent change of all the people per activity. And the next few graphs, which are on this slide and the next slide, show the visual representation of each person's score before and after the activity for each activity. So for example, this is with talking with other participants, drawing, moving on to the next slide, playing a computer game, reading a book, and the control group. So some of the conclusions that I found was actually, on average, the activity that contributed to the most short-term memory loss was the control group, which is pretty surprising. And as stated in my abstract, which was in my journal, this might have happened due to the fact that the participants might have started thinking about an entirely different topic, as they might have gotten bored during the 5 minutes that they had to do nothing. And that could have led them to forget what they had memorized earlier about, for example, the photo collage. On the other hand, reading a book actually contributed to no short-term memory loss, as the scores stayed the same on average and showed a 0% change in the scores of the participants. And this basically means that reading a book is actually one of the best activities to help curb short-term memory loss and prevent it, as it poses the least amount of distraction and focus compared to the activities. So as mentioned previously, the hypothesis for this experiment stated that playing a computer game would contribute to the most memory loss. And however, it was the second most potent after the control group, finishing at an average percent change of negative 41.5%. And as expected, playing a computer game actually takes a large amount of focus and concentration, which leads to distraction and hampered them from doing better on the Google form, as distraction can basically extinguish one's memory of what they had seen in the photo collage. And the 2 other activities, which were drawing and talking with other participants, were a little less potent, with negative 40% change. And basically, these 2 activities basically follow a similar principle, since the former, which is drawing, requires a high level of concentration, and the latter, which is talking with other participants, actually contributes to a high level of distraction, since most people were talking about a completely different topic. And some participants in the reflection forum who had done the computer activity, one of them actually described their experience on the reflection forum as playing the computer game required all my focus, so I was no longer thinking about the pictures. And yeah, that basically adds to the fuel that the fact that activities with a greater level of negative impact take higher levels of focus to execute, hence leading to more distraction and lower scores on the second Google form. And some ways to improve and a continuation of my experiment is, first of all, getting more subjects and participants, since I only had 12. And that'll basically reduce the spontaneousness of the experiment and make the results much more consistent. In addition, I could have had a greater age range of participants, since all of my participants were teenagers. And this kind of goes along with a way that I could continue my experiment. And since I already have a data set about how teenagers react to different activities in short-term memory loss, I could also do it with other age groups, such as adults and grandparents. And having more activities than just for, with a broader range of activities, so a broader range of daily life functions. So for example, eating food and things like that are tested. Or even multitasking, since in the ever-changing world, more people are doing two or three tasks at once. And from the reflection form, many of my participants said that the questions on the second Google form were a lot harder than the questions on the first form. And so I think another way I could improve my experiment is trying to have a roughly similar level of difficulty, trying my best to have a similar level of difficulty in the questions in both Google forms. And yeah, just real world applications. Studies have shown that damage to any of these structures in the mesolimbic pathway through repetitive short-term memory loss can lead to severe implications such as depression and more severely mental diseases such as Parkinson's. It's not going to happen through just, for example, short-term memory loss over maybe like one day, but repetitive short-term memory loss and bad habits can lead to this. So it is of crucial importance to understand this very crucial part of the brain and how people react to different activities to basically reduce the effect of these diseases on the global population. Here are some of my sources, some of the appendix for my forms in the computer game and the photos. And thank you so much for listening. Any questions?
Well, first, congratulations. This is a very terrific accomplishment. I guess my question would be about the age range. You said you did participants from 13 to 16. Did you consider maybe in the future experiment increasing the age range? Because I can assume that short-term memory will change when the age group changes as well.
Yeah, as I said in my ways to improve my experiment, I kind of talked about how in the future I could have a greater age range, for example, adults and grandparents, to see how they would basically, how the results would change since the age level changes. And since I already have a data set for teenagers of my age, maybe expanding it to different broader levels of age groups can maybe help continue and further represent the global population in my experiment.
All right, I have a question. So could you go back to your experimental design?
Oh yeah, sure.
Okay. So each person was given how many? Did they each do all 4 activities?
No, we actually split them into groups. Since there were 12 people in total and 5 activities, we actually had some people, we actually had 3 people for one activity and 2 people for another activity, but each person did 1 activity in total.
Okay, that makes sense. Yeah, so what I would say is, next time when you only have like 10, 15 people, right? 2 people per activity is not reasonable in the sense that like there's a lot of variability with respect to that. So I would personally suggest like if you have less people, maybe cut down the number of activities, right? So instead of doing like 5 really, because there's the 4 activities and then also normal, right? I think right as a control. So cutting it down is best, and maybe having just 1 or 2 activities on top of the control is what I would suggest.
Okay.
Yeah, and then the other thing is, looking into perhaps like some sort of more statistical analysis in the sense like, and I think this is something that like a lot of people could have done too, but like I think like this is more applicable to your type of project where you can essentially compare you can compare between the different ones and then actually use hypothesis tests and other tests to actually verify whether that that result is statistically significant, right? That's one of the things I would recommend. Aside from that, I thought it was a very good presentation. I really liked how like all the detail you had, especially in your slides. All right. Anyone else have any other questions for Audrey or Emily? Do you have any other? Okay, yeah, if Emily doesn't have any other questions, does anyone else wanted to ask Audrey a question about his project?
Yeah. So, were all your participants from like this country, or like were they international?
Yeah, all of them were educated students living in the US.
Okay. So for maybe like further, did you ever consider like having participants from like other countries to see how like maybe if like geographical region would play a factor?
Yeah, definitely. I think as I kind of stated in my ways to improve, I think what you said kind of goes along with getting more subjects, as kind of getting more subjects will kind of go with a broader geographic range as well as a broader diversity and genetic makeup. So I think that will definitely help representing more of the global population.
All right, other questions from the public? All right. Okay. Thank you so much, Atreya, for your presentation. Very nice job. So I'm gonna remove you from Spotlight and just mute yourself. All right. So just to conclude here, thank you guys all so much for coming today. And I think anyone who's spectating can speak to the fact that all of these products were extremely advanced for people of your age, and to do this amount of work and that little amount of time. You guys should be extremely proud of yourself. I know I keep saying that, but it's really true. You guys have done a lot of work. You guys have been dedicated to this for the last 3 to 6 months, and should really be proud of yourselves. Give yourselves a pat on the back for all the work that you guys have done. All right, so just a reminder that our award ceremony will be tomorrow from 3 to 3:30 p.m. Eastern Standard Time. So please be there. And we will also be awarding a $20 prize to the best journal entry if you did enter the journal. So again, thank you so much for coming, and hope everyone has a good night. Or if it's not night for you, then good day. I'll see you guys. Bye.